Good morning, students. So in this class, we are going to be continuing with the rest of the chapter integers. We have done exercise 1.1 and we have been clear with the idea of how to add and subtract integers. Now, keeping all these things in mind, let us proceed with the rest of the chapter. So we are going to start with properties of addition and subtraction of integers. Now, let's see the first property. Now you need to understand what is the meaning of the word property. Property means the characteristics or the features of addition and subtraction of integers. Okay, so when we add and subtract integers, there are certain rules and regulations that we need to follow, and some of the rules they directly imply. So these are what we are going to study in this first video. Okay, first section of this video. So let's look at the properties of addition and subtraction of integers. The first property is called the closure property, closure under addition and subtraction of integers. Okay, so let's look at this closure property. What does this closure property tell us? It tells us that if we take two integers, a and b. Now you must be wondering why a and b. A is not a number, it's a letter. B is also a number, it's a letter, right? So we take letters to replace numbers, to represent numbers. Why do we represent numbers using these letters? Because we can substitute any number in place of this a and any number in place of this b, any integer, right? So generally we take it as a and b, but these are actually integers. Okay, for example, a can be 1, b can be 2, a can be minus 30, b can be 49, any number, right? So that is why we take a, b generally. Okay, so now let's go into the closure under addition and subtraction. A and b are both integers. So the closure property tells us that if a and b are integers, then a plus b and a minus b are also integers. Okay, so that is what the closure property tells us. Closure property tells us that if we take two integers and add them, we get another integer. Whatever the answer is, that is also an integer. And closure property under subtraction tells us that if we take any two integers and subtract them, then whatever answer we get, that is also an integer. Okay, so summarizing, if we take two integers and we add them, we get an integer, and if we take two integers and subtract them also, we get an integer. So that is called the closure property of integers. Closure property under addition and subtraction. All right, so the next property is, before we start the next property, let us look at some examples to make this clear. The first example is, let's take 1 and 2 and add both the integers. When we add both the integers, we get 3, and 3 is also clearly an integer, right? So let's look at another example. Let's take two integers, minus 1 and 2. Now minus 1 is also an integer, 2 is also an integer, and when we add them, we get 1. Now I will not be repeating addition again and again. I will not be repeating the rules, that is minus, plus, minus, etc., because in the previous videos we have been repeating them over and over, and by now you should be well revised and well versed with what are the rules and how to add and subtract. Okay, so I'll be directly saying it. So if you do not know still, please watch the rest of the videos, the further uploaded videos, okay, the prior videos, and please make sure that addition and subtraction of integers is clear to you before you start this section. Now, again, repeating the same thing, minus 1 and 2 are both integers, and when I added them, I got 1, and 1 is also an integer. So clearly, a plus b, when two integers we take, we get another integer, right? So let's look at another example. 4 minus 2. We have taken two integers, 4 and 2, and we have subtracted them, we have minus them. So we get 2, and clearly 2 is also an integer, right? So that is what the closure property under addition and subtraction says. So let's take one more. Minus 3 and 2 both are integers. When we subtract them also, we get an integer itself. And which integer is that? Minus 4. So that means, again saying, when we take two integers and when we add them, we get an integer itself. When we take two integers and when we subtract them also, we get an integer itself. So now let's go on to the next property of addition and subtraction. Next property is called the commutative property under addition. Now, what does commutative property under addition say? Commutative property under addition says that when we take any two integers a and b, a plus b will be equal to b plus a. What does this mean? This means that when I add two integers, I get an answer, and that will be the same when I change the position of the integers and add them. That is, if I add a and then b or b and then a, it does not make a difference. The answer will be equal. Okay? So this is what the commutative property tells us. So commutative property tells us that if a and b are both integers, then a plus b is equal to b plus a. Okay, so let us make it clear using some examples. The first example is, let's take 1 and 2. 1 plus 2 is 3, right? So next is 2 plus 1. We interchange their positions, we exchange their positions. You can see 1 was first and 2 was second, then 2 is first and 1 is second. We got 1 plus 2 is 3 and 2 plus 1 is also 3. So as you can see, when we add two integers, it does not matter which number we add first. That is the position of integers. Even if we change them, it does not matter. The answer will be the same. So if you add 1 plus 2 or 2 plus 1, the answer will be 3 itself. Now let's take another example. Another example is minus 3 and 2. Let's a be minus 3 and b be 2. So minus 3 plus 2 is minus 1. Now let's change the positions. Let's put 2 first and minus 3 second. So 2 plus minus 3. Now 2 plus minus 3 is also minus 1 itself. Now you can see that the positions interchanged, but the answer is the same. So minus 3 plus 2 is also same as 2 minus 2 plus minus 3. So position interchanging does not make a change in the answer. The answer will remain the same. So that means minus 3 I can put first or minus 3 I can put second. 2 I can put second or 2 I can put first. It does not matter. The answer will be equal. Okay. So that is what the commutative property says. Again, commutative property tells us that if a and b are two integers, then a plus b will be the same as b plus a, which means that if I interchange or exchange the position of the integers when I add, it does not matter because the answer will be equal. Now let's look at the next example. Next example, we have taken two integers and we have subtracted them. Let's see, 3 and 2 are both integers. 3 minus 2 is 1. Now let's change the positions. Let's put 2 first and 3 second. 2 minus 3. 2 minus 3 is minus 1. So as you can see, when we subtract two integers and when we change their positions, then the answers will also change, which means a minus b is not equal to b minus a. When it was plus and plus, it was equal. But when it is minus and minus, it is not equal. So I can say that 3 minus 2 is 1, which is not equal to 2 minus 3, which is minus 1. So that means I can conclude that subtraction is not commutative for integers. Only addition is commutative for integers because a plus b equal to b plus a. But a minus b is not equal to b minus a. So I can conclude that subtraction is not commutative for integers. Now next we have associative property. The third property is associative property. Now what does this property mean? This property means, or this property tells us that when we take three integers a, b and c, and when we add them, okay, we have already learned that when we add three integers, we can either take the first two and add them first, or we can take the second two and add them first, right? So what do we do? First, when we see three integers, we take the first two and add them, we get an answer, and we add the answer with the third integer, right? Or we take the last two and add them, and whatever answer we get, we add it with the first one, and the answer will be the same, right? Now look here, bracket. Whenever you see a bracket, make sure that you solve the bracket first, and then you go for whatever is outside the bracket. So let's look at associative property clearly. When we take three integers a, b and c, and when we add the first two integers and then add the third integer, whatever answer we get will be equal to the answer that we get when we add the first number with the answer of the second two numbers added. Okay, that is what the associative property of addition tells us. Okay, so let us see once more. Let us make it clear using examples. Now let us take this example. Let us put a 2, b 3 and c 4. So let's look at this side. Let's look at the left hand side. So 2 plus 3 plus 4. Since there is a bracket, I should solve 2 plus 3 first. It's not I can solve, but I should solve. That is the formula, right? That is the way of solving. Whenever you see a bracket, you solve that first. So 2 plus 3 I need to solve first since they are inside a bracket. So 2 plus 3 is 5 and plus 4 will remain plus 4 itself. Now 5 plus 4 we get 9. So that means 2 plus 3 plus 4 is 9. Right? Now let's look at the second part. 2 plus 3 plus 4. The numbers are the same, but we can see that the bracket is with the second two numbers, right? So now let's see. Bracket means that we need to solve them first. So 2 remains the same. 3 plus 4 becomes 7. So that means I have 2 plus 3 plus 4 is 2 plus 7. Now 2 plus 7 is equal to 9. So I can see that if I add the first two numbers and then the third number, I get 9. And if I add the last two numbers and then the first number, then also I get 9 itself, which means that I can conclude that first two numbers added with the third number is equal as the first number added with the second and third numbers sum. So that is what the associative property tells us. Now let's look at the associative property. One more example. Let's take three integers -2, 5 and 1 and let's add them, right? First let's add the first two numbers. So -2 plus 5 is 3 and plus 1, the last number will remain the same, plus 1 itself. So 3 plus 1 is 4. So that means this one when I solve, I get 4. Now I take the same numbers, but I add the last two numbers first. So -2 will remain the same and 5 plus 1 will become 6. Now -2 plus 6 is 4. So as you can see, I got the same answer. And what does this mean? This means that even if I add the first two numbers first or the last two numbers first, the answer is going to be the same. So this is what is called the associative property under addition. So I can conclude that this is the same as this. That means the first two numbers added with the third number is the same as the first number added with the last two numbers sum. So this is what associative property tells us. Now let's look at the next property. The next property is called the additive property. Additive property tells us that 0 is the additive identity of every integer. Now, what does this mean? This means that a plus 0 is a. A plus 0 is a. Let us look at it carefully. We know that when we take any number, okay, a here is an integer. So when we take any integer and add it with 0, we get the same integer itself, right? That is obviously a universal fact. We have known this from our childhood days. We've known this from our younger classes. Whenever we add 0 to any number, we get that number itself. So therefore, we call 0 as the additive identity of any integer, right? Let's make this clear using some examples. The first example is 3 plus 0 is equal to 3. Here, 3 is the integer. When we add 0 to 3, we get 3 itself. So I can say that 0 is the additive identity of 3. Okay, let's look at another example. Minus 9 plus 0 is equal to minus 9. Minus 9 is an integer, and when I add 0 to an integer, I get the same integer itself. So what can I say? I can say that 0 is the additive identity of minus 9, right? Now let's look at one more example. 100 plus 0 is equal to 100. Now I have taken one integer, that is 100, and when I add 0 to the integer, I get the same integer. So what can I say? I can say that 0 is the additive identity of 100. So I can conclude that 0 is the additive identity of 3, 0 is the additive identity of minus 9, 0 is the additive identity of 100. So from these three examples, I can conclude that 0 is the additive identity of every integer, not just 3, minus 9 and 100, but every integer. Whatever integers you take and add it with 0, you're going to get the same integer itself. So we say that 0 is the additive identity of every integer. Now, in the next class, we will be continuing with our chapter. We will be doing exercise 1.2, and exercise 1.2 is based on all these properties. So make sure that you have well versed with the properties. Only then you will be able to do each and every question of exercise 1.2. And please study well and make sure that you complete your notes on time. Your notes will be sent along with your videos. So please make sure that you maintain a copybook and you complete your notes. Okay? Thank you. See you the next day.